At first glance, this looks like the same kind of problem as we did last time. And it may be, but we wouldn't be wrong to try to avoid extra work. So I'm going to factor x to the fourth out here. And I have x squared minus 4 left over. And for these two, I'm going to say I'm factoring out a 9. So I get... notice when I factor out a negative 9 from a positive 36, I get a negative 4. Okay, so when I do that, I see right away that x squared minus 4 is one of my factors, and x to the fourth minus 9 is another one. Well, I can do some more things with these, and hopefully you see right away that this can be divided up into x plus 2 and x minus 2. And then with a little more insight, sorry for the jerk around there, I can say x squared plus 3 and x squared minus 3. And I have, this is the difference of two squares. One of the squares is a little strange because it's x squared times x squared is x to the fourth, but it's still a square. And then I can also go a little bit further here. I can say x plus the square root of 3 and x minus the square root of 3. Okay, and then I combine that also with this part before and this part before and this part before. Okay, so here we go. It says x to the sixth, so I could have 6 roots. I have a lot, but let's see how many I actually have. I have x is equal to negative 2 for this one right here, okay? And then x is equal to positive 2 to go with the negative 2, right? And I'm not getting anything out of there. You could look at that as the sum of two squares. If I thought about 3 being the square root of 3 times the square root of 3, you could call that the sum of two squares. But I can't factor the sum when it's the addition of two squares. That's not happening. So I'm guessing that these are imaginary, okay? Well, I'm not guessing. I know they're imaginary because I can't factor that. And then I also would say that x is equal to negative square root of 3. And then I would say that x is equal to positive square root of 3. Okay, so I have 4 roots here, or solutions, or zeros, or places where the graph hits the x-axis. Okay, and the square root of 3 is about 1.73, so it happens pretty close. Happens pretty close to 2 there. But anyway, it's zipping back and forth in a small area. This is a positive 1 out in front, and it's an even exponent. So we know this is coming from, down here, and it's going back and forth pretty quick and then going back up. So did I do too much there? 1, 2, 3, 4, 5. Yeah, I guess I did. Okay, well, maybe I'll put a graph of this exactly in the notes to show you exactly what it is. I was just going to try to do something real quick there. But I'm not sophisticated enough to do that.